15 hidden billion-dollar stones. Most people have never heard of. Most people think they know the world's rarest gems. But the stones that truly hold billion-dollar potential are the ones nobody talks about, because almost nobody even knows they exist. Across abandoned mines, extinct volcanoes, forgotten civilizations, there are gemstones so scarce that the entire world's supply could fit in the palm of your hand. Stones so undervalued that the market hasn't even realized what they're worth. And yet their geological stories are beyond anything you've ever seen. In today's episode, we're uncovering 15 hidden gemstones, rarer than diamond, stranger than science can explain, and so overlooked that the moment the world discovers them, their value will never follow traditional rules again. Stay with me, because once you see what's been hiding beneath the earth, you'll understand why these stones may be the next billion-dollar frontier. Ranked 15th, Hauyne. The neon blue gem that shouldn't exist in nature. In the world of gemstones, value usually follows visibility. Diamonds, emeralds, sapphires. Everyone knows their names, so everyone assigns them worth. But Hauyne is an exception so extreme that it breaks every rule of the market. It is a gem so rare, so chemically improbable, and so visually electric. Yet most people on Earth, including many jewelers, have never even heard its name. And that silent anonymity is precisely why Hauyne is emerging as one of the most underestimated billion-dollar category potentials in the entire mineral world. Hauyne's story begins in volcanic chaos. It forms only when molten rock cools under a razor-thin set of conditions. Conditions so delicate that even minor shifts in temperature or sulfur levels will erase it before the crystal ever fully forms. When researchers returned to Italy's extinct volcanic fields to track its origin, they were stunned. Entire mountains of basalt, yet only microscopic traces of Hauyne. Years of digging may reveal a single crystal, and an even smaller chance that it is clean enough to cut. To date, the number of fine, faceable Hauyne gems is estimated to be in the low hundreds worldwide, making it rarer than Painite during its peak scarcity. But scarcity is only the first piece of this hidden puzzle. The second is market invisibility. Because Hauyne is almost never seen in jewelry stores, the global trade never built a price ladder for it. No standardized grading, no consistent auctions, no mainstream awareness. Its value, therefore, sits in a strange vacuum. Extremely high rarity, extremely high visual impact, but near zero public recognition. Investors call these stones sleepers, gems whose value remains dormant simply because the world hasn't woken up to them. And then comes the paradox that shocks even veteran mineralogists. Hauyne shouldn't survive at all. Its sulfur-rich structure is so fragile that most crystals collapse or fade long before reaching the surface. The few that do survive eruptive pressure are geological accidents, exceptions so improbable that each one feels like a natural glitch. Its neon glow, stronger than most blue stones known to science, comes from unstable lattice pathways that defy typical mineral physics. The result is a gemstone that looks synthetic, behaves unstable, and exists in quantities so tiny that they barely register statistically. So why does Hauyne qualify as a hidden billion-dollar stone? Because scarcity on this scale, combined with a visual signature unlike anything else, creates a perfect storm for future collector markets. Not because a single stone will sell for $1 billion, but because the entire category, if rediscovered by the collector world, could explode in value the way Paraiba tourmaline did in the early 2000s. Yet here is the twist that keeps Hauyne locked in obscurity. Fewer than 1% of gemstone professionals have ever handled one. Most enthusiasts have never seen it, not even online. It is a treasure hidden in plain geological sight. And if a gem this rare, this radiant, and this misunderstood has stayed invisible for centuries, what else is the world overlooking? Ranked 14th, Poudretteite, the candy pink ghost of Quebec. If Hauyne was a geological accident, then Poudretteite is a geological whisper, so faint, so fleeting, that for decades scientists weren't even sure it existed. The gem was first identified in the 1960s in Quebec's Poudretteite quarry, a site famous not for precious stones, but for producing obscure minerals in quantities so small they barely filled laboratory vials. Poudretteite appear there only as grains, tiny, translucent pink fragments too insignificant to be considered gemstones. For nearly half a century, the world assumed it would remain that way. A mineralogical footnote, interesting but worthless. Then in 2000, everything changed. A gemstone dealer in Myanmar presented a pale pink crystal so unexpectedly large and so impossibly clean that researchers were convinced it had to be a new species. But when the gem entered a laboratory, something astonishing happened. The spectroscopic signatures matched the forgotten samples from Quebec. The impossible crystal was, without question, the world's first fastable Poudretteite. Overnight, a mineral once dismissed as microscopic dust had become one of the rarest gemstones ever recognized. But rarity alone doesn't make Poudretteite a hidden billion-dollar stone. Its true potential lies in what followed. The Myanmar discovery turned out to be a once-in-history event. Despite years of searching, miners could only unearth a handful of crystals, most riddled with fractures or cloudiness. Fine, transparent stones, stones worthy of jewelry, are so few that the global total may be counted on one or two hands. Even elite collectors whisper about it rather than display it. Owning one feels less like purchasing a gem and more like holding a geological anomaly. Its color, a soft cotton candy pink with a spectral glow, looks delicate but unmistakably refined, almost like the ghost of a morganite stripped of all impurities. And yet the majority of professional jewelers have never heard of it. Poudretteite doesn't appear in mainstream gem courses. It's not sold at auctions. It rarely surfaces in trade shows. The world of gemstones has effectively forgotten it, leaving a microscopic market with massive untapped potential. Here lies its billion-dollar angle. When a gem is this rare, this beautiful, and this unknown, it occupies the same pre-boom position once held by Paraiba tourmaline, Alexandrite, and even tanzanite. In other words, Poudretteite is a category waiting to be awakened. A single significant discovery, a museum exhibition, or even a viral documentary could ignite global awareness. And in the gemstone world, awareness is the fuse that detonates value. Yet the quarry in Quebec is long past its productive years. Myanmar's pocket appears exhausted. No new deposits have emerged anywhere on Earth. What remains are only a few spectral, pink survivors. And a lingering question that collectors can't ignore. If the world nearly overlooked one of the rarest pink gems ever found, how many more billion-dollar secrets are still hiding underground? Ranked 13th, Benitoite, California's blue fire that disappeared overnight. There are gemstones whose value comes from age, pressure, or myth. And then there is Benitoite, whose value comes from something far more unlikely: extinction in real time. The gem burns with an electric blue so vivid, so sharply luminescent, that under ultraviolet light it erupts into a star-like white glow. It is beautiful in a way that feels engineered, almost theatrical. But Benitoite's brilliance hides a truth no investor or collector can ignore. The world's only commercial source of this gemstone has already closed, turning its supply curve into a vertical cliff. Benitoite was first discovered in 1907 in the mountains of San Benito County, California. At first, miners mistook it for sapphire. The blue was just as striking, but the crystal structure didn't match any known gemstone. When scientists examined it, they realized they were looking at an entirely new species, one found nowhere else on Earth. Almost immediately, Benitoite became California's official state gem. Yet ironically, even this title failed to bring it into mainstream recognition. To this day, most Americans have never heard of it. The reason isn't a lack of beauty, but a lack of stones. The original mine operated on a thin, unpredictable vein of hydrothermal mineralization. Imagine a geological thread, narrow, fragile, and impossible to replicate. Each time miners followed it, the vein splintered or vanished. For over a century, they dug through serpentine rock, chasing flashes of blue fire. And then, one day, the vein ended. The mine shut down. The supply froze. Overnight, Benitoite transitioned from rare to geologically extinct in the wild. This scarcity gives Benitoite something few gems possess: absolute supply certainty. No new deposits are expected. No secondary mines have ever been confirmed. Nature seems to have chosen a single mountain to host this stone, and that mountain is no longer producing. For collectors and investors, this creates a once-in-history dynamic, a gem whose future value isn't speculative, but structurally guaranteed by the absence of new material. Yet here is the paradox. Despite its rarity, benitoite remains a hidden commodity. Its market awareness is astonishingly low. Jewelers rarely stock it. Auction houses seldom list it. Many gemologists encounter it only in textbooks. Its name lacks the global visibility that fuels mainstream demand, leaving it as one of the world's most undervalued ultra-rare stones. But anyone who has seen benitoite under ultraviolet light knows that this obscurity won't last forever. Its optical behavior is so distinctive, so unmistakable, that all it takes is a single museum exhibition or cultural moment to ignite recognition. When that happens, the supply vacuum will collide with global interest, and the market will have nowhere to turn for more stones. Which raises the next question in our investigation. If a gem as stunning as benitoite can vanish without warning, what happens to stones that were already nearly impossible to find in the first place? Ranked 12th, Grandidierite, the teal stone that vanished before it rose. Before the gemstone world ever had a chance to appreciate it, Grandidierite had already begun disappearing. Its color, a deep teal that shifts between ocean green and shadowed blue, feels like the meeting point of two worlds, the calm of aquamarine and the gravity of sapphire. Yet what truly defines this stone isn't its beauty, but the astonishing fact that almost the entire global supply came and went before the gem market even realized what it was worth. Grandidierite was first identified in 1902 on the southern coast of Madagascar, in a windswept region where mineral discoveries were often overlooked due to remoteness and political turbulence. The specimens found were opaque, interesting to mineralogists, but worthless to jewelers. For decades, the stone lived only in museum drawers and geology papers. The world treated it as a scientific curiosity, not a future treasure. Then, in the early 2000s, something unexpected happened. A tiny pocket of translucent grandidierite was uncovered. Stones that allowed light to pass through them, revealing that haunting teal glow for the first time. For a brief moment, the gem world held its breath. Was this the beginning of a new sapphire-level phenomenon? Could Grandidierite finally rise into global awareness? But the excitement was short-lived. The pocket yielded only a small handful of faceable material. So small, in fact, that many dealers never saw a single stone. And just as quickly as it appeared, the source vanished. Attempts to reopen the site failed. Additional exploration found nothing. Within a few short years, the window had closed forever. This created one of the rarest supply dynamics in modern gemology, a gemstone that never had a chance to establish a market price. It was too rare to circulate widely, too briefly available to build momentum, and too unfamiliar for investors to understand. As a result, Grandidierite sits in a paradoxical position, one of the world's rarest and most striking gems, yet almost completely unknown outside a narrow elite of collectors. Its billion-dollar potential lies not in its current price, but in its structural invisibility. When a gem is both extraordinarily rare and globally under-recognized, it exists in what economists call a latent demand zone, a sleeping market that, once awakened, can surge in value faster than traditional assets. Paraiba tourmaline experienced this. Alexandrite experienced this. Grandidierite may be next. But here is the factor that makes it even more mysterious. Scientists still don't fully understand why Grandidierite forms so rarely. The mineral requires a near-perfect alignment of boron-rich fluids, precise pressure conditions, and a volatile geological environment. One shift in chemistry and the gem fails to crystallize at all. So the question becomes, if Grandidierite vanished before the world recognized its value, what other stones might be quietly disappearing before their rise ever begins? Ranked 11th, blue color change garnet. The invisible chameleon worth more than its name. In the gemstone world, garnet is a word people think they understand. It sounds familiar, safe, common. Most imagine a deep red stone, pretty, affordable, and anything but rare. That's exactly why blue color change garnet is so dangerous to underestimate. It hides inside one of the most ordinary names in gemology, while behaving like one of the rarest phenomena on Earth. Unlike the red garnets sold in mall jewelry, this variety is born from a geological glitch. In a few isolated deposits, most famously in Madagascar and East Africa, trace amounts of vanadium and chromium slip into garnet's crystal lattice at the exact right moment, under the exact right temperature and pressure. When that alignment happens, something almost supernatural appears, a garnet that changes color like a living ember. But here is where the story breaks away from anything resembling ordinary garnet. Blue color change garnet doesn't occur in reliable veins. There is no large industrial mine dedicated to it. Instead, it emerges as a statistical accident inside mixed garnet gravels. One stone here, none there. Sometimes nothing for years. Miners don't chase it, they stumble upon it. Dealers don't build inventory around it. They wait, hoping one will surface. Most never do. Ask a jeweler about diamond, ruby, emerald. They have charts, lists, long histories of pricing. Ask them about blue color change garnet, and you'll often get a blank stare. The gem is so rare that even seasoned professionals may go their entire career without handling a single stone. And yet the few that do reach the top tier, strong blue in daylight, vivid red in warm light, high clarity, precision cut, quietly trade at prices that shock collectors who still think of garnet as inexpensive. Per carat, top stones can rival or exceed fine sapphires. In some private sales, they've approached the territory of elite Alexandrite, the king of color change gems. Not because of branding, not because of marketing, but because those who truly understand rarity know how microscopic the supply really is. This is where its hidden billion-dollar potential emerges. Blue color change garnet sits at a strange intersection. It belongs to a common family with a rare mutation, so the public assumes it's cheap. It exhibits a world-class optical phenomenon, true color change, on par with, and sometimes sharper than, Alexandrite. Its global supply of fine stones is so small that even a modest surge in awareness would overwhelm availability overnight. Economists call this a mispriced asset. Gemologists call it a sleeper. Either way, it fits the same pattern we've seen with Paraiba tourmaline and other once obscure stones. A gem hiding in plain sight, waiting for a single cultural spark, a museum exhibition, a celebrity piece, a viral documentary to awaken global demand. Scientifically, it remains a puzzle as well. Why do only a few tiny pockets of Earth produce this color change effect in garnet, while thousands of other deposits never do? The answer lies in an improbably narrow mix of chemistry. Iron, manganese, chromium, vanadium, and aluminum must all align within tight boundaries. Shift the recipe slightly, and the stone becomes brown, red, or simply dull. Hit the formula perfectly, and you get a crystal that lives between two worlds of color. So blue color change garnet stays where it has always been, misunderstood by name, underestimated by markets, and quietly coveted by the handful of collectors who know what they're looking at. And that leads us to the next step in our investigation. If a gemstone hiding behind the word garnet can carry this level of rarity, beauty, and unrealized value, what happens when we move into stones so rare that even their names have never reached the public at all? Ranked 10th. Jeremejevite, the desert. Ice blue crystal with no real supply chain. Some gemstones are rare because they are hard to find. Jeremejevite is rare because the Earth almost never creates it in the first place. It forms only in hyperspecific geological environments. Ancient desert pegmatites where the chemistry aligns for just a moment, long enough for a few pale blue crystals to grow before the window closes forever. The result is a gemstone so scarce, so sporadically produced, that the global market can't even define what normal supply should look like. In truth, Jeremejevite has no supply chain at all. Most of the world's facetable Jeremejevite comes from a remote region of Namibia, where the desert wind cuts across dry plateaus and leaves nothing but scattered granite and quartz. Here, in cracks barely wide enough for a finger, miners occasionally spot tiny shards of ice blue crystal, delicate, elongated, and deceptively elegant. But these finds are unpredictable. A miner may go months, even years, before discovering a single piece worth keeping. There are no veins to follow, no deposits to map. Jeremejevite simply appears, or it doesn't. This unpredictability has kept the gemstone hidden from public knowledge. Jewelers don't stock it because they can't rely on it. Dealers rarely promote it because they don't know when or if they will ever see it again. And collectors? Most have never held one. Even among professional gemologists, Jeremejevite is often recognized only as a textbook oddity, mentioned briefly, then forgotten. Yet the few high-quality stones that do surface reveal something astonishing. Jeremejevite possesses a clarity and brilliance that rival top-grade aquamarine, but with a cooler, sharper tone, an Arctic blue that seems carved from frozen light. Under the right conditions, it displays a crisp pleochroism, shifting subtly between blue, colorless, and pale champagne hues. Its optical behavior is refined, sophisticated, and almost entirely unknown to the world. This invisibility is exactly what gives Jeremejevite its billion-dollar potential. Like Painite and Taaffeite before their market awakenings, Jeremejevite exists in a zone of ultra-rare supply and ultra-low awareness. Economists call this a compressed market, a scenario where rarity is extreme, but demand has not yet formed, simply because the public doesn't know the asset exists. Should awareness ever rise, the supply would collapse instantly under even modest demand. There are simply not enough stones. And here's the scientific mystery. Why does the Earth produce Jeremejevite so rarely? Researchers believe it requires a fleeting alignment of aluminum, boron, and fluoride in pegmatites, an alignment that may occur only once in a geological era. Once the fluids shift, the opportunity disappears forever. The desert preserves the crystals, but not the conditions that made them. Which brings us to the question driving this investigation. If Jeremejevite marks the boundary between rarity and near impossibility, what happens when we uncover a gem even rarer than this? Ranked 9th. Taaffeite, the only gem discovered already cut. It wasn't found in a mine. It wasn't dug from the earth. It was discovered inside a gem that had already been cut, an optical fingerprint hidden in plain sight. Taaffeite is the only gemstone in history identified after leaving nature. What followed is one of the strangest scarcity stories in gemology. Once Taaffeite was officially classified, scientists attempted to locate its natural source. It wasn't easy. The first few decades yielded almost nothing, just a handful of crystals in Sri Lanka and southern Tanzania. Even today, nearly 80 years after the discovery, gemologists still struggle to pinpoint consistent deposits. Taaffeite doesn't occur in neat veins or predictable pockets. Instead, it appears randomly alongside spinel, hiding in the shadows of more common minerals. Because of this, Taaffeite has no stable supply chain and never has. Miners don't actively look for it because it doesn't occur in minimal concentrations. Dealers rarely promote it because stones arrive unpredictably, sometimes one per year, sometimes none. Most jewelers have never stocked it, and the public? The vast majority doesn't even know the gemstone exists. This obscurity contrasts sharply with Taaffeite's intrinsic value. Fine specimens exhibit a plum to lilac color unlike any other gem, richer than kunzite, deeper than morganite, and more refined than spinel. Its clarity and brilliance rival sapphire. And its rarity? Some experts estimate that Taaffeite is 1 million times rarer than diamond, a statistic dramatic enough to reshape its future, yet still ignored by mainstream markets. The billion-dollar potential emerges from this very disconnect. An ultra-rare gemstone with world-class aesthetics, yet almost zero public recognition. A gem that should be a household name among collectors, but instead exists as a scientific footnote. It is precisely this imbalance, beauty without awareness, rarity without demand, that defines a sleeper asset waiting for ignition. Should Taaffeite ever achieve mainstream visibility, its microscopic supply would evaporate instantly, and prices would accelerate in a manner similar to Paraiba tourmaline's meteoric rise. But there is another layer to its mystery. Scientists still debate the exact geological sequence that forms Taaffeite. It appears only under narrow conditions where beryllium, magnesium, and aluminum converge, a combination rare enough that many pegmatites never achieve it. Some researchers believe Taaffeite is a boundary mineral, forming at the intersection of processes that almost never overlap. If true, then every Taaffeite crystal is a geological accident, an anomaly that survived against probability, which leads us to our next question. If a gemstone this rare could hide for decades in plain sight, mistaken for something else, how many more billion-dollar secrets lie undetected in the world's gem markets? Ranked 8th. Musgravite, the ultra-rare sibling that outprices diamonds. There are gemstones people chase, and there are gemstones so rare the market can't even form demand for them. Musgravite lives in that impossible space, worth more than diamonds, yet invisible to nearly everyone. From the moment of its discovery, Musgravite broke every rule of the gem market. Diamonds, rubies, emeralds, these stones remain valuable because they have steady supply chains. People can mine them, trade them, forecast them. Musgravite offers none of that stability. Its deposits are so microscopic, so inconsistent, that in some years the entire global production amounts to only a few crystals, not a few kilograms, not a few dozen stones, a few crystals. And yet, despite this extreme scarcity, Musgravite remains a ghost in the public eye. Most jewelers have never seen it. Most gemologists have never handled it. Auction houses rarely list it because there simply aren't enough stones to establish a pattern of value. Even collectors who specialize in the rarest gems often learn about Musgravite through whispers. Rumors pass between dealers who trade in anomalies rather than commodities. What makes Musgravite even more intriguing is the quality of the stones themselves. Fine specimens display a subtle, smoky lilac tone with a near-metallic depth, something between sapphire's elegance and spinel's fire. Under magnification, the gem reveals a clarity and structural precision that rivals some of the best corundum ever found. Combine this beauty with microscopic supply, and the result is inevitable. Musgravite consistently outprices diamonds of similar size and clarity. In some cases, it even surpasses high-end ruby on a per-carat basis. But here lies the paradox that shapes its billion-dollar potential. Musgravite is too rare to market. For a gemstone to achieve mainstream value, the world must know it exists. Influencers, jewelers, auction houses all require a minimum supply to tell its story. Musgravite does not provide that. Instead, it occupies an economic limbo where rarity is absolute, but demand is still forming. It is a gem whose value is driven more by absence than by presence. And beneath this economic mystery lies a scientific one. Musgravite forms only when beryllium-bearing magmatic fluids undergo precise pressure and heat changes, conditions so specific that even in gem-rich regions, the mineral fails to crystallize. When it does, the resulting stones are often too flawed to cut. The handful of faceable specimens represent a convergence of geological coincidences so unlikely that scientists still debate how they occurred. So the question becomes, if Musgravite can outprice diamonds without the world even noticing, what happens when we reach a gemstone whose rarity makes Musgravite look common? Ranked 7th. Alexandrite, Russian origin, the lost color shift treasure. Most gemstones shimmer, a few glow, but only one seems to change its identity depending on the light that touches it. Alexandrite, especially the legendary Russian origin material, remains one of the most extraordinary optical phenomena ever pulled from the earth. Under daylight, it flashes a cool forest green. Under incandescent light, it transforms into a deep wine red, as if the gem carries two souls at once. But beyond its hypnotic color shift lies a truth the world has nearly forgotten. The original Russian sources that produced the finest Alexandrite ever known have been depleted for decades, leaving behind a treasure whose rarity is approaching extinction. The story begins in the Ural Mountains during the 1830s, a time when Russia was undergoing rapid industrial exploration. Miners searching for emeralds cracked open a vein and found crystals unlike anything they had seen. Green in sunlight, red in candlelight. At first, they believed the stones were anomalies, curious but insignificant. But when scientists examined them, they realized they were witnessing a new mineral species altogether. Named in honor of Tsar Alexander II, Alexandrite quickly became a symbol of imperial wealth and national pride. But the glory didn't last. The Ural deposits were shockingly small, consisting of narrow pockets scattered through mica schist. For several decades, they produced stones of unparalleled quality, crisp, saturated greens, and dramatic ruby-like reds. Then, almost without warning, the pockets ran dry. By the early 1900s, fine Russian Alexandrite was already considered scarce. By the mid-20th century, it was nearly mythical. Today, most people who claim to have seen Alexandrite have actually seen laboratory-grown material or low-grade stones from secondary sources. What the world rarely acknowledges is that true Russian-origin Alexandrite, natural, unheated, and with strong color change, exists in quantities so small that many gemologists go their entire careers without handling one. Auction houses recognize their rarity but are limited by supply. A fine specimen may appear once a decade. This scarcity fuels its billion-dollar potential. Alexandrite sits at the crossroads of rarity, optical phenomenon, and historical legacy, qualities that define the most sought-after gemstones in human history. Yet public awareness remains surprisingly low. Ask the average jewelry buyer about emerald, ruby, sapphire. They'll know them instantly. Ask about Alexandrite, and most will hesitate. A gemstone this extraordinary should be a cultural icon, but instead it lingers in obscurity, overshadowed by bigger marketing and larger industries. Scientifically, its formation borders on miraculous. Alexandrite requires the presence of both beryllium and chromium, elements that almost never coexist in the same geological environment. The chemistry must align perfectly, the temperature must fall within a razor-thin range, the host rock must shift but not fracture. Nature rarely achieves this alignment, and when it does, the result is fleeting. So what are we left with? A gemstone capable of two identities, born from impossible chemistry, tied to a vanished Russian landscape, and largely unknown to the world outside expert circles. And as we move deeper into the list, one question becomes unavoidable. If a gem as famous yet misunderstood as Alexandrite can slip into obscurity, what happens to stones that never had fame to begin with? Ranked 6th, Paraiba tourmaline, Brazil origin, the electric blue supply collapse. There was a moment in Brazil's history when the earth glowed, a neon blue fire, unlike anything seen before or after, erupted from a single hillside. Today, that fire is gone, leaving Paraiba's original color as nothing more than a fading memory. But what the world often forgets, what most never knew, is that the original Brazilian Paraiba tourmaline existed for only a moment in geological and commercial time. It appeared suddenly, rose meteoric in value, then collapsed into near-complete disappearance. And today, the mines that produced it lie silent, their veins exhausted, their tunnels abandoned. The electric blue phenomenon that stunned the gem world in the 1980s and 1990s has become a vanished resource, a color that geology may never replicate again. The story begins in 1989, when miners in Paraiba State, Brazil, unearthed a stone unlike anything seen before. Under ordinary light, it radiated an impossible neon, a blue so saturated it seemed digital decades before digital screens existed. When shown to the international trade, it ignited a frenzy. Prices skyrocketed. Dealers flew across continents. Collectors fought for access. But behind the excitement was a fragile truth. The deposit was small. The geology was unstable, and the yield was microscopic. Within just a few years, the mine's output plunged. By the early 2000s, the original vein had deteriorated to the point of near abandonment. Attempts to reopen the area brought little success. Brazil had produced one of the most visually electrifying gems in human history, and then lost it almost immediately. The modern market often confuses Paraiba's story. Stones from Nigeria or Mozambique are sometimes grouped under the same trade name, but experts know the difference instantly. Brazilian origin Paraiba is chemically distinct, visually superior, and geologically irreplaceable. Its neon glow is sharper, purer, more concentrated, and its supply, frozen in time. Every Brazilian Paraiba tourmaline in existence today is part of a finite, rapidly shrinking inventory, cut, sold, resold, and never replenished. This is where its billion-dollar potential emerges. When a gemstone possesses a signature color that no other natural mineral can replicate, and when its only true source has collapsed, its value shifts from rarity to inevitability. Even modest increases in global awareness could ignite explosive demand. But here's the twist. Outside of gem circles, most people have never heard of Paraiba tourmaline. They don't know its story, its disappearance, or the science that makes it glow like molten neon. And that obscurity is a loaded spring. Paraiba is a sleeping giant, an extinct geological marvel that the mainstream market hasn't discovered yet. Which brings us to a deeper question. If the world nearly lost Paraiba without realizing what it had, what other stones are vanishing in silence, waiting to be recognized before they're gone forever? Ranked 5th. Ammolite grade. A+, the fossilized rainbow reaching extinction. Ammolite isn't a gemstone, it's a fossilized rainbow, an echo of a vanished ocean. When you hold it, you're holding the last light of a creature that died 70 million years ago, and that light is disappearing again. The story centers on a single region, the Bear Paw Formation of Alberta, Canada. Here, a prehistoric seabed preserved ammonite shells under unique geological conditions: pressure, mineral infusion, and airtight confinement. Only in this narrow band of earth did the fossil layers achieve the perfect thin film structure needed to produce ammolite's color. Remove any variable, humidity, compression, microfractures, and the material turns dull, brown, or chalky. In other words, Ammolite is as dependent on perfect fossilization as it is on perfect geology. For decades, most specimens were collected as fossils rather than gemstones. It wasn't until the 1980s that the world realized these prehistoric shells could be cut, polished, and stabilized into jewelry. The discovery was revolutionary, but short-lived, because the more miners extracted, the more they realized a harsh truth. Only a tiny fraction of ammonite fossils produce gem-quality color, and of those, an even smaller percentage achieve AA+ grade, the neon-intense material that collectors now prize. Today, gem-quality ammolite is drastically declining. The Alberta mines are tightly regulated by environmental and First Nations oversight. Large sections of the Bear Paw Formation are now protected land. Climate conditions, shifting sediment layers, and erosion threaten what little remains. Miners report that AA+ color zones, once accessible, are now increasingly rare, buried too deep or structurally unstable. Some experts predict that within one generation, the supply of top-grade ammolite may disappear entirely. Despite this, ammolite remains a hidden market. Many jewelers have never handled it. Many collectors don't know it exists. Its status as an organic gemstone places it outside mainstream classification systems. And while auction houses occasionally present fossilized ammonites, they rarely highlight the gem-quality material that commands premium value. This gap between rarity and recognition creates the same billion-dollar potential seen in stones like Paraiba and Alexandrite before their rise, an asset so limited that even moderate public awareness could explode demand overnight. Scientifically, ammolite is irreplaceable. No modern process can recreate its micro-layered structure. No other fossil yields comparable color, and no other location on Earth has produced material of equal quality. Once the Bear Paw Formation is exhausted, grade AA+ ammolite, this fossilized rainbow of an extinct ocean, will be gone forever, which leaves us with a haunting question. If a gem forged over 70 million years is disappearing right now, how many other ancient treasures are slipping away before the world even knows they exist? Ranked 4th. Painite. Once the rarest gem on Earth, now slipping back into dark scarcity. For half a century, Painite was a rumor, 3 crystals locked in museums, no more. Scientists debated whether it was a mineral or a myth. Today, the myth is returning, as Painite slips back into scarcity once thought permanent. Painite's story began in the 1950s, when British gemologist Arthur Payne examined a mysterious brownish-red crystal believed to be a variety of tourmaline. But under spectroscopy, the stone revealed an unexpected combination of zirconium, boron, and rare earth elements, an impossible chemistry that didn't match any known mineral. It wasn't tourmaline at all. It was something entirely new. And with that discovery, Painite entered scientific legend. For decades, no miner, dealer, or gemologist could find another specimen. The Burmese terrain was too dangerous, the deposits too elusive, the host rocks too unpredictable. Painite became a mineralogical myth, studied in photographs, whispered about in academic circles, but effectively extinct. It wasn't until the early 2000s that new pockets were discovered. For a brief moment, it seemed the gem world might finally have access to a treasure that had lived in obscurity for half a century. But that moment was short-lived. While the discoveries increased the total number of painite specimens, very few were clean enough to cut, and even fewer were large enough to matter in the jewelry world. Most pieces were fragments, scientifically interesting, commercially insignificant. High-quality painite remains so rare that many collectors will never see one in their lifetime. And now, as political conditions shift and mining zones grow more restricted, the flow of new material has slowed to a trickle once again. Painite's billion-dollar potential comes from a unique economic paradox. It was once the rarest gem on Earth, it briefly became obtainable, and now it is vanishing again, slipping back into the same darkness from which it emerged. Yet public awareness remains astonishingly low. Outside of academic mineral collectors, few have heard its name. Even within the trade, some jewelers mistakenly classify it as garnet or spinel due to its reddish-brown color. But the true value of painite lies not in its appearance, but in its narrative and scarcity. Its chemical structure is unlike anything else in the gem kingdom. Its formation requires a geological alignment so improbable that scientists still debate how it happened. And its historical rarity, 3 specimens known for decades, gives it a prestige no modern gemstone can replicate. Today, painite sits at a crossroads. Its market is fragile, its visibility low, and its supply diminishing once more. It is a gemstone trapped between discovery and disappearance, which leads us to the next question in our investigation. If painite, once the rarest gem alive, can fade back into obscurity, what happens when we encounter a stone whose rarity has never been understood at all? Ranked third, Serendibite, the shadow black million-dollar stone with no market awareness. Some stones become famous because the world sees them. Serendibite becomes valuable because almost no one ever will. A million-dollar gem that hides inside the darkest shade of black. The story begins in Sri Lanka, where early mineralogists identified Serendibite only in microscopic grains, tiny inclusions trapped in metamorphic rock. It was scientifically interesting, but commercially irrelevant. Only later did larger crystals emerge from Myanmar, and even then, the term larger is misleading. Most pieces were slivers, fragments, or distorted masses barely suitable for study, let alone for setting. Gem cutters who worked with it often described the material as uncooperative, resisting symmetry, light return, and polish. But then something extraordinary happened. A handful of clean, cuttable Serendibite stones surfaced, so few that their total combined weight would not fill a small vial. These gems possessed a unique optical character, a dense midnight black body punctuated by subtle blue and green undertones, visible only when the stone is tilted under intense light. It is a beauty that doesn't shout. It whispers, rewarding only the careful observer. And perhaps that subtlety is why the mainstream gem world has never embraced it. Yet rarity tells a different story. If we compare global availability, diamonds might as well be gravel. Sapphires are plentiful. Even Paraiba tourmaline seems abundant. Serendibite, on the other hand, exists in quantities so microscopic that the entire known supply of fine material could fit in the palm of a single hand. Auction houses cannot feature it consistently. Collectors cannot build inventories. The trade cannot form a market. There simply aren't enough stones to create demand, even though, paradoxically, the few transactions that occur reach extraordinary price levels. This creates one of the most unusual economic profiles in gemstone history, a stone with confirmed million-dollar value, yet zero global awareness. No advertising campaigns, no celebrity endorsements, no jewelry brand claiming it. Serendibite lives in the shadows because its supply is too limited to sustain a spotlight. Scientifically, its formation is just as elusive. Serendibite requires the collision of calcium-rich, boron-rich, and aluminum-heavy metamorphic processes, conditions so rare that they almost never occur together. Even when they do, the resulting crystal is usually opaque or fractured, A gem-quality specimen represents a geological accident of the highest order. So here Serendibite remains, a treasure that hides its brilliance in darkness, a million-dollar gemstone without a market, a rarity so extreme that most gemologists will never encounter it, not in their careers, not in textbooks, not even in museums, which raises the question driving us deeper into this list. If Serendibite can command $1 million while nearly invisible to the world, what kind of stone could possibly outrank it? Ranked second, red beryl, the American ruby that costs more than gold, platinum, and diamond. The earth has produced countless emeralds, rubies, sapphires, but for every 150,000 diamonds, nature allows just one red beryl. It is not mined. It is won, like a geological lottery ticket. Red beryl was first discovered in the Wah Wah Mountains, an isolated region where volcanic gas channels once pumped superheated beryllium and manganese through fractures in the rock. The conditions required to form this gem are so precise, temperature, pressure, chemistry, fluid composition, that geologists estimate they occur in only one location on Earth with any consistency. If the chemistry shifts by even a fraction, the result is ordinary beryl, aquamarine, heliodor, emerald. The deep raspberry red color of red beryl is not just uncommon, it borders on the geologically impossible. This impossibility is exactly why red beryl is sometimes called the diamond of the desert. Fine rubies may reach extraordinary prices, but ruby deposits exist across multiple countries. Red beryl has no such luxury. Only a few pockets in Utah have ever produced material clean enough to facet, and mining them has always been a delicate, high-risk undertaking. The host rock is brittle, access is treacherous, and yields are microscopic. In some seasons, miners report finding no gem-quality stones at all. Economically, red beryl exists in a category few gems ever reach, a stone whose per-carat price regularly exceeds diamond, platinum, and even high-end emerald. Yet public awareness remains shockingly low. Jewelers rarely display it because they can't secure supply. Auction houses avoid it because they can't assemble enough pieces to create consistent valuation. And because the stones are so small, often under half a carat, most collectors don't realize how rare they truly are. The billion-dollar potential emerges from this visibility gap. Red beryl is one of the only gemstones whose rarity is orders of magnitude beyond the icons of the trade, yet whose story has never been told on a global scale. If even a fraction of ruby or sapphire buyers understood its scarcity, demand would overwhelm supply instantly. There simply are not enough stones to support mainstream interest. In economic terms, red beryl sits at the edge of a hyper-deflationary market, one where any significant rise in attention could trigger explosive value escalation. Scientifically, it remains a marvel. The same geological processes that formed it millions of years ago are no longer active. The volcanic systems are extinct. The chemistry cannot be recreated. What exists today is all the red beryl the world will ever have. And so the question grows sharper as we climb toward the number one stone. If red beryl, a gem rarer than diamonds by several magnitudes, remains unknown to most of the world, what kind of stone could possibly outrank it in rarity, obscurity, and billion-dollar potential? In first place, Imperial blue JADEITE, Guatemala, the true hidden billion-dollar contender. Among all the rare gemstones in the world, those born of volcanic fire, desert chemistry, or ancient oceans, none has a story as overlooked, misunderstood, and wildly underappreciated as Imperial blue jadeite from Guatemala. Most people have heard of Burmese jadeite, the vibrant green stone revered in Asia for centuries. Yet almost no one outside of archaeological and gemological circles knows that deep within the volcanic highlands of Guatemala lies a jadeite so rare, so structurally unique, that it may be the true hidden billion-dollar contender of the entire gemstone world. The origins of this stone trace back over 3,000 years when the Maya civilization sourced jade not from Burma, as many assume, but from local volcanic deposits. What the Maya prized most was not green jade, it was blue jade, a color born from the delicate interplay of iron and titanium within jadeite's mineral lattice. This hue is so difficult to achieve naturally that only a handful of geological environments have ever produced it, and Guatemala's is arguably the finest. In its purest form, Imperial blue jadeite displays a saturated oceanic blue, deep yet luminous, smooth yet crystalline, like a fragment of midnight carved from the earth. Yet the world lost track of it. After the collapse of Maya trade routes, the knowledge of Guatemala's blue jade deposits faded. When Spanish colonizers arrived, they overlooked the material entirely. By the 20th century, the blue stone of the Maya was considered a myth, until a team of archaeologists rediscovered fragments of it near ancient ceremonial sites. But even then, almost no modern explorers knew where the original source was. That rediscovery did not lead to modern mining. Instead, it exposed a startling truth. The original deposits are largely exhausted. The few remaining pockets are scattered across remote mountainous terrain, controlled heavily by cultural and environmental protection zones. Most material found today is too fractured or weathered to cut. High-grade, gem-quality Imperial blue is almost non-existent, making it rarer than both red beryl and Painite in cuttable form. And yet, the global market has no idea. While Myanmar's green jadeite commands millions at auction, Guatemala's Imperial blue, arguably more geologically unique, remains invisible, overshadowed by centuries of trade dominance. Jewelers do not request it because they don't know it exists. Collectors overlook it because they assume all jadeite comes from Myanmar. The supply is microscopic. The awareness is near zero. This is precisely why Imperial blue jadeite holds billion-dollar potential, not because a single stone sells for $1 billion, but because the category itself is positioned for explosive discovery. It has everything: historical significance, cultural depth, geological impossibility, and a supply so small it could fit in a briefcase. The moment global awareness begins, demand will collide instantly with a finite, unreplenishable inventory. And that is the hidden reality. While other gems fade, reappear, or fluctuate, Imperial blue jadeite is quietly approaching a point of absolute extinction. Its rise, if it ever comes, will be sudden, dramatic, and irreversible. Because sometimes the world's greatest treasure is not the one everyone fights for, but the one nobody realizes is disappearing. And now you've seen them. The stones the world forgot. The gems so rare, so improbable, that entire lifetimes can pass without anyone ever holding a single piece. Some of them disappeared before their value was ever understood. Some exist only in fragments, protected in museums or locked away in private collections, and others may already be gone forever. But here's the part that stays with us long after the countdown ends. These gemstones were never just about price. They remind us how much of Earth's story we still haven't uncovered, how many miracles of pressure, heat, chemistry, and pure chance are hiding beneath our feet, waiting for someone to notice. So if this journey opened your eyes to a world you didn't know existed, tell me in the comments, which hidden gemstone shocked you the most? I read every single one, and if you want to keep exploring the rare, the mysterious, and the stories the world almost missed, make sure you're subscribed because the next episode goes even deeper. Until then, stay curious, stay fascinated, and remember, sometimes the most valuable things on Earth